Welcome to today's Explainer. We're going to tackle a massive problem in modern business, having a ton of data, but very little actual insight. In a world where data sets are some of the most valuable assets a company can own, we are literally generating quintillions of bytes of data. But, well, here's the catch. Raw data on its own doesn't actually mean anything. Gathering data and presenting it so that it actually drives business growth, those are two completely distinct activities. Today, we're going to explore the critical framework that bridges that gap. So, let's dive right in. Here is our roadmap for the Explainer today. We'll start with the data visualization myth, define presentation architecture, look at where art meets science, hit the core objectives and scope of DPA, and finally, walk through the 7 steps to build it. All right, let's jump straight into Section 1, the data visualization myth. I really want you to ask yourself this question. Is data presentation just data visualization? Because, a lot of people think that if you make a pretty chart or a colorful dashboard, your job presenting data is totally done. We constantly confuse the two, thinking that if we have a visualization tool, we have a complete data strategy. But spoiler alert, we don't. Take a look at this typical traveler spend dashboard. You've got nice bar charts, weekly breakdowns of expenses. It's highly visual, right? But this visualization is really just the paint and interior design of a much larger structure. Without a proper foundation, this dashboard might look amazing, but it might not actually give the C-suite or line of business executives the exact insights they desperately need to make decisions. There's actually a hard line between the two concepts. Visualization is really just one single element of the much broader data presentation architecture. See, visualization is merely finding the best way to present data that has already been chosen. Data presentation architecture, or DPA, on the other hand, is the much broader skill set of determining exactly what data, on what schedule, and in what exact format needs to be presented in the first place.
Which brings us to Section 2, defining presentation architecture.
There is this phenomenal quote from Kelly Lott that establishes DPA as the critical missing link in business intelligence. It's a set of skills aimed at identifying, finding, modifying, formatting, and presenting data in a way that ideally conveys meaning and provides true insight. The really crucial takeaway here is that you need a unique, dedicated mindset to do this right. It's an entirely distinct field. It's not just an IT task of maintaining servers, and it's not just a business task of defining KPIs. It exists in this unique middle ground. It's a specialized skill set required to provide business intelligence solutions with the data scope, delivery timing, and format that will most effectively support your strategic organizational goals. Moving on to Section 3, where art meets science. DPA beautifully weds two completely different worlds. It takes the rigorous science of numbers, data, and statistics, like those complex descriptive, diagnostic, predictive, and prescriptive analytics, to discover valuable information. But then, it marries that science with the human arts of communication, organizational psychology, change management, and visual design. This mashup is exactly what makes information not just mathematically accurate, but practically usable, relevant, and actionable for human decision-makers. Let's look at Section 4, Core Objectives of DPA. The two core objectives boil down to pure efficiency and effectiveness. First, to utilize data to impart information in the most efficient method feasible. That means the data is pertinent, timely, comprehensive, and actionable enough to actually affect behavior and decisions. Second, to deliver it as effectively as feasible. This means deliberately minimizing the noise, the complexity, and all that unneeded detail, based strictly on the demands and tasks of each specific audience. It's about giving them exactly what they need, without any distracting clutter. Next up, Section 5, the scope of DPA. Notice how incredibly specific these 6 scope points are. It starts with defining the significant meaning required by each audience member in every scenario, and then obtaining the proper data with the right historic reach and detail. But then it gets into the logistics, determining how often the data needs to be refreshed and the optimal presentation moment. Like, how frequently does the user actually need to view that data? Finally, it covers using suitable display styles and developing delivery techniques based specifically on a user's daily job duties, their physical location, and their tech access. It's a highly tailored approach. All right, let's get practical with Section 6, 7 steps to build it. Here are the first 4 steps, which make up your strategy and setup phase. Step 1 is identifying requirements, really understanding the purpose, the audience, and the types of data. Step 2 is collection and processing, where you gather data from various sources, clean it, transform it, and aggregate it.
Step 3 is where you choose your visualization technique, selecting the charts or visual elements that best represent those insights. And Step 4 is selecting the right tools and platforms based on your exact needs.
For instance, Step 4 might involve choosing a powerful business intelligence platform, like the one we're looking at here. Software like this acts as the workbench for your data, letting you drag and drop assets and instantly display things. But remember, a tool like this is only effective if you've done the hard architectural planning in Steps 1 through 3 first. Let's round it out with our final 3 steps, the build and maintenance phase. Step 5 is creating the architecture itself, developing the framework for data storage, processing, and the visual layers. Step 6 is implement and test. You build it, integrate it, and test against business rules to ensure it functions accurately without mistakes at the source. Finally, Step 7 is optimize and maintain. A DPA is absolutely not a set-it-and-forget-it project. It requires continuous maintenance, performance optimization, and updates to adapt to changing data and user needs over time.
So, by now it should be pretty clear that extracting actionable insight from raw data requires so much more than just throwing some numbers into a chart. I want to leave you with this provocative thought. When it comes to your organization's data, are you just painting the walls, or are you architecting the entire house? Stop just visualizing and start architecting a true strategy to drive your success.
Right now, literally quintillion bytes of raw data are being generated out there. It's an absolute flood of information. But raw data on its own, it's really just noise. Today, we're going to master how to transform that overwhelming volume into actionable insights. We'll be looking at data visualization, which is simply the visual depiction of data and information, and how tools like dashboards, charts, graphs, and maps help us easily spot trends, outliers, and patterns. Let's get right into it. Henry D. Hubbard, the creator of the periodic table of elements, once said something that really hits the nail on the head. He noted, "There is magic in graphs. The profile of a curve reveals in a flash a whole situation, the life history of an epidemic, a panic, or an era of prosperity." It's so true, right? A simple curve informs the mind, awakens the imagination, and ultimately it convinces. So here is our roadmap for today. 1. The power of visualization. 2. Data presentation architecture. 3. Dashboards for decision-making. 4. The magic in graphs. 5. Tables and matrix reports. And 6. Best practices in design. Section 1. The power of visualization, finding the signal. The psychology behind all this is actually really fascinating. Think about it. 65% of us are visual learners. So staring at massive, raw spreadsheets makes it nearly impossible to spot any meaningful trends. Without visual solutions, you're just drowning in data. Visuals act like a life raft, enabling much faster decision-making and a far deeper analysis of really complicated data. Moving right along to Section 2, Data Presentation Architecture, beyond just visuals. Now, data presentation architecture, or DPA for short, isn't just about picking out a pretty chart. It's a specific skill set. It weds the hard science of data and statistics with the arts of visualization and communication. The goal? To provide actual, actionable business intelligence. It's about figuring out exactly what data, on what schedule, and in what specific format it needs to be presented to drive real results. Here's what DPA looks like in the real world. Your audience changes everything. The C-suite, for example, needs high-level, highly relevant, strategic information to steer the whole ship. But your line of business managers, they need deep, granular operational details to drive their daily actions. Good DPA means you're tailoring that exact scope to whoever is looking at it, entirely cutting out the noise. Section 3. Dashboards for decision-making. The command center. Let's talk about the Data Visualization Dashboard. This is an interactive tool that enables you to manage important metrics across numerous financial channels all in one single place. Take a look at this Tableau example showing traveler spend analysis. By visualizing these data points and summarizing the results, you generate reports that give your audience the ability to view company performance at a glance. And honestly, creating these kinds of clear reports is one of the most effective ways to build strong working relationships with clients. It explains what the company is doing and why. Now, there are numerous levels of dashboards, from company-wide metrics to specific team values. But for any dashboard to actually be helpful, it absolutely must be automatically or routinely updated to reflect the present state of affairs. Section 4. The magic in graphs, a visual taxonomy. Let's look at some specific graphs, starting with the bar chart. This is easily one of the most used types of data visualization out there. It's incredibly useful when your data can be divided into distinct categories, like revenue earned across different years or the number of car models produced by an automaker. Here, we're looking at the change in economic value added, or EVA, for Hindustan Unilever Limited. Bar graphs make it a breeze to compare data, highlight discrepancies, and spot historical highs and lows. To add a little zing, you can make the bars colorful. You can even use stacked or side-by-side bar charts to dissect the data for an even deeper examination. Now, while bar charts compare distinct categories, the line chart or line graph joins various data points together, displaying them as a continuous progression. You'll want to utilize line charts to observe trends in data, usually over time. Think stock price fluctuations over 5 years or monthly website page visits. For instance, here we're tracking the movement of HUL's share price. It's a basic, beautifully simple method for representing changes in one value relative to another. And a quick pro tip, for an even better visual impact, you can shade the area under the line, or, if feasible, even combine the line graph with a bar chart. Next up is the classic pie chart, sometimes called a circle chart. This is a circular graphical representation of statistical data that's segmented to demonstrate numerical proportion. Basically, the arc length of each slice and its area is proportionate to the value it depicts. The corporate world and the mass media use these extensively, and they can be served up in a number of ways. Looking at this breakdown of Hull shareholder categories, it's instantly obvious who holds the largest piece of the pie. But a word of caution here. For a better representation, always keep the number of wedges limited. If you have too many tiny slices, it completely ruins the visual clarity. Okay, what happens when you have massive amounts of data points and you're hunting for a relationship? That's where the grouped scatter plot comes in. By mapping two different variables, like the irrigated area against the number of agricultural holdings shown here, analysts can visually identify hidden patterns, correlations, or relative concentrations that would just completely blend into the background of a standard spreadsheet. Shifting gears from data points to timelines, we have the Gantt chart. If you manage projects, you probably know and love this one. It's brilliant for tracking a project's timeline and its activity dependencies. It clearly depicts which tasks literally must be accomplished before others can even begin, laying out the entire critical path of a project in one easy-to-read view. And rounding out our graph section is the bubble chart. Think of this kind of like a scatter plot but leveled up. It aesthetically displays links between 3 or more variables. By varying the position, the size, and the color of the circles, you can pack a ton of information into one space. Like seeing the varying proportions of professions for people who generate programming languages. It's a really powerful way to make complex data pop. Section 5, Tables and Matrix Reports, Structuring the Raw Data. Now, I know what you're thinking. Tables and crosstabs involve a lot of reading. They might not seem as instantly visual as a chart, but they are absolutely essential for executing direct comparative analysis. You're arranging qualitative data on X and Y axes to communicate a single, essential message. And you can actually make them highly visual. Try adding features like color gradients for heat mapping. It elevates a simple grid of numbers into a genuinely powerful analytical tool. Finally, Section 6, Best Practices in Design, Your Roadmap to Success. So how do we pull all of this together? Here is your concrete roadmap for success in data visualization. Step 1, know your objective. Are you being exploratory and searching for answers, or declarative and stating a known fact? Step 2, keep the audience in mind. You have to tailor that level of detail, whether you're presenting to the C-suite or your line managers. And Step 3, invest in the best technology. Remove those data silos and use the right tools to effortlessly bring your data to life. Which brings us to a final, really important question for you to ponder. What story is your data actually telling? If you're just reporting raw spreadsheets, you aren't communicating, you're just adding to the noise. It's time to start using data presentation architecture to communicate actionable insights. Turn that noise into a clear, convincing signal and watch how it awakens the imagination. Have you ever just stared at a massive spreadsheet filled with endless rows and columns and felt completely overwhelmed? Honestly, we've all been there. Raw data on its own can be incredibly difficult to decipher. It's kind of like a giant puzzle with no picture on the box. But today, in this explainer, we're going to transform those boring, intimidating numbers into compelling visual stories. And we're going to do it using 6 specific, incredibly powerful charting tools. Which brings up a really important question, right? If you have a massive data set, how do you actually visualize 1 million data points without creating just a confusing, unreadable mess? Well, the secret isn't just cutting down your data. It's actually about using the exact right visual tool to make all that complex information instantly digestible. So here is our agenda for today. 1. Mapping location data. 2. Finding hidden connections. And 3. Time and distribution. All right, let's jump right into section 1, mapping location data. When it comes to displaying any type of location data, whether we're talking postal codes, state abbreviations, country names, or custom geocoding, standard maps are an absolute no-brainer. If your data is tied to geographic information, a map is literally the simplest and most effective approach to illustrate that relationship. Think about tracking insurance claims by state, product export destinations by country, or even automobile accidents by postal code. The key here is that there should always be a correlation between the location and the patterns in your data. For example, mapping the average state GDP growth in India instantly conveys regional economic trends. You definitely don't need to read thousands of rows of state-by-state numbers. The visual shading handles all the heavy lifting for you, revealing that geographical correlation immediately. But what happens when a standard map gets a little too crowded? Sometimes individual data points get totally obscured by overlapping marks on a regular map. And that is where the density map comes in, as our hero solution. Instead of plotting individual points, density maps indicate patterns and relative concentrations. This makes them particularly useful when you're dealing with massive data sets that include a ton of data points in a limited geographic region. To put that into perspective, when mapping cyclone hazard-prone districts in India, using standard dots for every historical storm would just create a solid, unreadable block of ink. No way you could read that. But by showing density, the highly vulnerable coastal zones, those darker concentrations you see become undeniably clear. It reveals patterns that might otherwise be completely hidden.
Okay, moving right along to section 2, finding hidden connections.
Enter the scatter plot. This is a highly useful tool for displaying several unique data points on a single graph to find those hidden connections. A scatter plot allows you to really examine the relationship between many variables, revealing whether one variable is actually a good predictor of another or whether they just tend to vary independently. Take a look at the connection between the number of agricultural holdings and the irrigated area in hectares across different districts in Andhra Pradesh. Each dot represents a unique district data point. By plotting them on an X and Y axis, we can immediately evaluate the relationship, the dispersion, and spot any weird outliers without getting bogged down in raw tabular data. It's a real game changer. But actually, we can take this a step further. While bubbles aren't exactly their own distinct sort of visualization, using them as a method radically enhances scatter plots. It's a simple 3-step process. Step 1, you start with your standard scatter plot. Step 2, you vary the size of the circles based on a third variable. And step 3, you add color to represent even more variables. Suddenly, boom, you've upgraded to a dynamic bubble chart. When visualizing the professions of people who generate programming languages, varying the circle size digests enormous amounts of data at a single glance. We can instantly see the expected heavy concentration of computer scientists and engineers, sure. But the smaller bubbles reveal mathematicians and even psychologists are in the mix, mapping out a really complex, multivariable relationship beautifully. And for our final category, section 3, time and distribution. Let's talk about the Gantt chart. Originated by the American engineer Henry L. Gantt, this chart consists of a simple rectangular grid that represents a project's timeline or activity changes across time. It depicts tasks that must be accomplished before others may begin, as well as the allocation of resources, all drawn to a precise timescale. But importantly, and people often forget this, while it's famous for project management, this graphic can actually depict any data connected to a time series. In a concrete project schedule, the horizontal axis represents time and the vertical axis shows the activities. You can clearly track the expected time, critical paths, and dependencies, meaning you can see exactly which predecessor tasks absolutely must be finished before the next specific job can begin. Conceptually, this acts as a highly effective visual timeline. Imagine day 1 is your project start. By day 5, a predecessor task is completed, which unlocks the ability to start the next phase, leading to a dependent task finishing on day 10. The position and length of the horizontal bars give everyone, from foremen and engineers to top management, a quick visual indication of the actual status and anticipated sequence of interconnected activities over time. The whole shebang, right there in front of you. Finally, we have the histogram. This is the absolute ultimate way to illustrate the distribution of your data among various groups. Histograms divide data into discrete categories, sometimes known as bins, and provide a vertical bar proportionate to the number of entries or the frequency inside each of those categories.
Instead of staring at a massive list of individual ages, a histogram groups the frequencies into easy-to-read discrete bins. You immediately see how many people fall into the age 10 bucket, the age 15 bucket, and the 20-plus bucket. It instantly reveals the shape and the overall distribution of your population. It just makes sense.
So, let's briefly recap the categorical toolkit we've built today. You have standard maps for location correlation, density maps to clarify overlapping concentrations, scatter plots to test relationships between two variables, bubble charts to layer in 3 or more variables, Gantt charts for managing sequential timelines, and histograms for mapping frequencies and distributions. I want to leave you with this really powerful quote from Henry D. Hubbard, the creator of the periodic table of elements. He said, "There is magic in graphs. The profile of a curve reveals in a flash a whole situation. The curve informs the mind, awakens the imagination, convinces." I mean, that perfectly captures the true value of data visualization, doesn't it? It's not just about making a report look pretty. It's about making complex information immediately clear and actionable. Which brings us to our final thought. The next time you open a massive, intimidating spreadsheet, don't just stare at the raw numbers. Ask yourself,